I'm Stephen Farmer, and I'd like to welcome you to On Air, the first in a series of podcasts from Altitude Angel. I'm joined by Richard Parker, our CEO, and Phil Binks, our head of ATM. Hope you enjoy what you're about to hear. Please share your views and opinions if you're watching on YouTube in the comments below, or you can email us at hello@altitudeangel.com. So I'm going to start by just talking about a few news stories that we've seen the last few weeks in the news, and some interesting developments from Altitude Angel. So first of all, the last few weeks we've seen some big stories come out. One was regarding Royal Mail. They've invested in 500 drones. They're going to be flying mail to the islands and highlands, I think. And also last week, I think we saw National Grid have announced they've got a big investment in their drone fleet. So I'll give this one to you, Richard, first off. What do you think this means for the industry?
Well, it's great news, isn't it, to see big enterprises investing in the use of drones. It's obviously great for the manufacturers. It's great for use cases for the drone economy. I think one of the big challenges, though, is that from what we understand about, for instance, the Royal Mail deployment, is that it's still effectively one pilot to one drone. So whilst it's a step forwards, it's still not the leap that industry really needs to break the link between a human pilot and one drone. So it'd be very difficult to imagine how we might scale that operation, which is taking place out in the Highlands, and put that, for instance, over a city like London or in a place like Munich, etc. It's not really going to scale very well. So again, on the national grid side of things, again, very similar. Very good to be able to see clever use of technology to improve safety outcomes, monitoring, etc. But again, these are all very limited scenarios. Very difficult to imagine those scaling in the current way that they're set up.
Binksy?
Yeah, I think it's really, really good. The national grid thing, I think it benefits several things. Health and safety for one. Why are we risking putting people at height when a drone can do the task? So it just demonstrates what improved safety of the operation, because people climbing pylons, I can imagine being, one, quite challenging, and two, do you have to shut down the electricity in order before you climb a pylon? I don't know, I'm not in that industry, but there looks to be significant safety benefits it brings. But for me, it's all about, it's the airspace. How are you going to make sure you're not adversely affecting other airspace users? And of course, National Grid is a perfect demonstration of this, because straight away you've got power lines which you're inspecting, so no other aircraft is going to go alongside those power lines. So automatically, it strikes me as being a great way to demonstrate BV loss operations, because an element of safety is naturally implied around that drone to keep it safe from other airspace users. So bring it on. More use cases, the better. And it just demonstrates the real benefits drones can bring.
I think it does raise some interesting questions, though. I mean, we don't really know much about the way that airspace is going to be arranged and organised in either the Royal Mail expansion or also the network, the National Grid. So, for instance, are these going to operate in an OTAMD area, in a TDA, for instance? I get what you're saying about them being infrastructure that you typically wouldn't find GA around, but also the drones could potentially cause an issue to other aircraft with a flyaway, etc.
Yeah.
So it'd be interesting to see what constraints the CAA are still going to place around that makes that something which could still be quite difficult to scale.
I think, yeah, when you start to go to beyond visual line of sight, you can go from more than, as Richard alluded to, a 1-to-1 ratio, one pilot to one drone, you go one to many drones. Then you need some way of monitoring and ensuring that the drone is doing as expected. Because as soon as you get a flyaway or the drone is no longer behaving as expected, there's some sort of safety mechanism must kick in.
Yeah.
So there needs to be that sort of safety net, monitoring, conformance alerting capability, and then an action needs to follow that when things aren't behaving. So lots and lots of stuff to do, but as a first step, I think it's brilliant.
I think looking at both of those use cases, the big question for me was, and it comes from an Altitude Angel point of view, is, say for example with National Grid, what happens when those power lines intersect with either a major road network or the rail network? And we know that National Rail, for example, are using drones. So what happens where if they're flying a drone down a railway line and there just so happens to be an inspection going on the National Grid, who's going to deconflict those drones? What kind of airspace do they need?
Yeah.
Yeah.
I think there's some interesting points that you bring out there, but I think again, in these two specific examples, those are probably not massive concerns, because they're firstly very far apart from each other, and I think secondly, they're still very human-centric operations, right? So from a deconfliction point of view, there is a remote pilot for every vehicle. How remote that pilot is, I don't think we understand in either scenario yet. It could be on site for all we know, could be done from a remote operations centre. But either way, I think as Philip said, it is a fantastic stepping stone to prove the efficacy and the benefits of drone technology in two vastly different industries. But the critical steps about integration don't seem to have been factored in here.
Yeah, I mean, as you alluded to, airspace management is still required. We still need to make sure that drones are deconflicted from each other as well as other airspace users. I mean, that is absolutely critical. We can't make the airspace any less safe than it is today. So whatever those systems, sensors, networks, we need to make sure there's a single point of truth and people can act or work from a single point of truth. So Network Rail, they'll know about their own drones, but they might not know about everybody else's. But of course, this is where UTM comes in. You can provide that single point of truth. And this isn't just for unmanned vehicles, this is for manned and unmanned vehicles. You can have that complete picture, and that's where we need to work from. If we start to build all the sensors and the whole situational awareness comes together, then we can start to build this ecosystem, which is absolutely required in order for the scalability of these drone operations. So, yeah, let's do a crawl, walk, run approach, and we appear to be now almost moving out of that crawl phase into that walking phase, and it's brilliant. The more we can do, the more we can support, the better.
Okay, so you mentioned their sensors, Phil. We actually put our story out the last few days with regards to ASDB, and we're looking to extend or widen our ASDB network.
ADSB.
ADSB
It's easy for you to say.
It is. So, Richard, what's the thinking behind that?
So ADSB is a technology which I think many people watching will understand as something which is predominantly used by crewed aircraft today, although it is increasingly something which, particularly on the commercial side of drone platforms, increasingly is being carried on board as a transponder. But it's a means of electronically broadcasting some information about where that aircraft is, as well as the identity of it, to a series of receivers on the ground. Now, at Altitude Angel, we have for many years consumed lots of different sources of position information, one of which is ADSB, and we use a number of commercial third parties today to pick up what we would say is kind of like the macro scale picture. So big commercial aircraft or any large general aviation traffic, as well as in some instances much smaller general aviation traffic, providing there's good coverage. And I think it's the coverage, which is one of the predominant reasons that we've decided to invest in our own proprietary network, is to address a gap in coverage, which principally exists today. ADSB network was never really envisaged for super low to the ground coverage. It was never really built for that purpose. Obviously, types of aircraft that are being tracked are quite often quite high in the sky, so it makes sense to put the transmitters as high in the sky as possible and everything else on the ground as low as possible. But this is the challenge. This network was never envisaged for drone traffic below 400 feet. So you have a coverage issue. And the other issue is the existing networks today kind of work a little bit on a kind of almost a semi-volunteer basis. So most of those networks feature a component of hobbyists that have kind of, very helpfully deployed, cheap hardware, antennas, etc. Sometimes 100 quid's worth of hardware, and they've popped that up on a pole on their chimney, and they're picking up position reports from aircraft nearby. But it takes some time for that journey to occur. So, for instance, seeing that aircraft, processing it on the hardware, sending it off to the aggregator, and then being able to pick that up, that can sometimes be over a minute. And a minute is quite a long time if you're traveling at 180 miles an hour, 200 miles an hour over ground. So we had to try and plug that gap, because obviously increasingly, I think certainly here in the UK, but abroad as well, the aviation authorities are considering mandating, a higher use of ADSB, which is great. But without solving these problems in how you collect this data, it's very difficult for a UTM organisation like ourselves to be able to pick up that data and use it in a meaningful way. There are other challenges as well, but maybe we'll talk about some of those in a minute.
I mean, I think this almost leads us on as well to the TMZs that I think Royal Mail were looking to use in the in the Highlands, a transponder mandatory zone.
Yeah, that's right. Yeah. Again, they have their advantages and disadvantages, really. The trouble with TMZ is you need everybody in the TMZ to be participating. So they must have a transponder on board because it says exactly that's what it says on the tin. The rules are before you enter that airspace, have a transponder so you're broadcasting who you are and everything. However, what happens if a transponder fails when you're operating that airspace? Does that aircraft suddenly disappear and you can no longer see them? It's a big problem. Or somebody inadvertently goes into that airspace. So it's all well and good having participating traffic, but when you get non-participating traffic in there, now you're in a spotted bother. So there's many elements. There are lots of little elements like that which are good, but you're going to have safety nets to make sure if something fails, something else can take over and see the object in the sky still. So that's one big problem. Other thing with the TMZ, you've got to be an ANSP, an air navigation service provider, to provide a service. You can't just have anybody managing that airspace. So you've got to be a licensee or certified ANSP. So that's going to offer new challenges as well, because as we've already said, it's likely these TMZs are going to be very, very low, sub 500 feet. Now that's often below ATC radar. If you move away from the airport, it doesn't take long, not far away from that radar where you cannot see below 500 feet. So how are they actually going to manage this? Are they going to expect different sensors to make sure the TMZ, nothing's drifting into those TMZs inadvertently? So in principle, it's a safety net, but it shouldn't be relied upon.
Yeah, I was just going to say, sorry, Steve, on the TMZ side of things, the point you made there was kind of the third point about why we've invested in our own network, right? Because with something like Arrow, the technology that we're rolling out to create safe zones effectively for all aviation traffic, if you don't have a transponder on board, you are effectively invisible.
Yeah.
So simply having a rule that says you should carry a transponder isn't good enough for a company like us if we are trying to safely navigate participating traffic through an airspace. So one of the key reasons that we've got that data feed in our network is to be able to use the other sensors that we've deployed through Arrow to work out when there is an aircraft in the vicinity that isn't carrying a transponder. And in that way, we're able to sort of elevate the safety of that region by being able to corroborate one source of information with another. And again, we were finding that really challenging, Steve, with the latency and the coverage issues we were getting with the commercially available ADSB feeds today.
So when we say transponder, does it have to be ADSB? What's the...
You lit the touch paper, haven't you? I mean, in the aviation sense, when you say a transponder, yes, probably. But from a drone's perspective, there are much better technologies available. I mean, if the goal is to ensure that the lowest common denominator is met, ADSB is a great, easy thing to do because actually lots of helicopters, police helicopters, medical choppers are carrying equipment on board that allows them to see ADSB broadcast. But again, the key there being the D in ADSB means dependent, and it's dependent because someone has to have the equipment and someone has to turn it on. And secondarily, it's effectively operating on a broadcast frequency, a radio frequency, and there are limitations to how much information we can cram into a particular location. And ADSB was never designed to factor in there could be 1,000 drones in a square kilometre or 10,000 drones in a square kilometre, and we're going to start to encounter all sorts of challenges if that's the primary mechanism. So there are alternatives. Remote ID in the US, which is just the standard for describing, again, another, on the one end, another radio broadcast, but on the other end, something called network remote ID, which is basically a nice way of saying we have a digital transmission mechanism to cryptographically identify a drone and have none of the scale problems that exist. And actually, from a lowest common multiple, it's probably a lot easier and more accessible for new entrants to the drone market to use, an internet-based solution for identity rather than something which requires proprietary hardware, which has although the cost has come down, it's still a cost. It's quite an expensive one.
Yeah, I mean there are lots and lots of various challenges around here. When I hear about a transponder to me with an air traffic control background is a big black box on an aircraft, 4-digit code, and you've got to put in the 4-digit code, or the pilot puts in the 4-digit code, which the air traffic controller has set. Now, those transponders are quite big, quite heavy, very expensive, but they've been through all this certification process because they have to be reliable. There's a safety element to it. There's no way a small drone can carry that big black box on board. But so ADSB is a fantastic jump to, it jumps that problem to get some very, very small ADSB things. Another issue around ADSB is, and just like a lot of these things that use a common frequency, is he who shouts the loudest is the one that's going to be heard. So if you've got an aircraft shouting a lot louder, broadcasting at far more watts than anything else, it'll black out anything else in that immediate area and therefore can't be heard or can't be seen. So it adds a problem. Don't get me wrong, it's a great safety net, but there are limitations to it, and we must be cognizant of them.
It is a useful technology, but as you've said there, that you said two things, right? The radar, the aviation transponders typically rely on a radar first to pass over the aircraft, right? And it's the energy from that radar which triggers the transponder to pulse back with the information. In this scenario, we're not going to be getting the benefit of that, right? So even if we could miniaturize all of this equipment, and even if we could then solve some of those other challenges, we still got the primary issue, which is we're not going to see it, right? And then the secondary aspect is even those types of ATM transponders still have those same scale limitations built in as well. So we really want to be avoiding that. The piece that's really key for us as well is when we're, effectively anybody can pick up these ADSB transmissions, right? Anybody can just, go and buy a bit of hardware, and we're talking cheap, like sub £100, and then put it on the highest point they've got on their property and probably pick up aircraft 30, 40 miles around. And that's the issue, because it's also possible for someone to broadcast in that frequency, right? And there are programs available on the internet which allow you to broadcast those same frequencies that we think are coming from aircraft. So this makes it really difficult to rely on the information that we're picking up on ADSB systems, although there are mitigating strategies, for instance, being able to do something called multilateration, which is looking at effectively multiple position reports from different antenna that you have and then just checking the time signatures. But it's a lot of overhead around a system which was never really designed for trust and authenticity, which is why we kind of absorb all of this information into our platform and then combine it with everything else that we have to create. Effectively, it's like an ADSB plus. I hope that term never gets coined, but it's that.
Well, you heard it here first. If it does,
it's that ability to be able to trust something which is inherently quite untrustworthy. I think that's
not too dissimilar to GPS today either, is it? GPS can't be relied upon because it can be spoofed. So, and that's why I'll probably going to stick my head on the chopping block here, that you don't get GPS approaches to UK airfields because of the element of safety around it. You'll use more traditional beacons and stuff like that, because how do you know when GPS is being spoofed? And that's a critical part. Therefore, you need other safety nets. But it's a really useful device for the majority to get around and to give a rough idea of where your position is. You tend to need a backup device to actually confirm that the position is there.
I think it just comes down to, all the time we get this at AA a lot, right? We get people saying, have you thought about this technology, or have you thought about that technology for scenario A or for scenario B? And quite often that's very well intentioned, but most of the time people are proposing using a technology for something it was never meant for. And whilst it might be a solution which gets you sort of halfway there or is good for the 90 percentile use cases, aviation can't work like that. We have to use the technologies the way that they're designed in order to rely on them properly. So again, this is why we don't use ADSB in the company for navigation, right? We don't use ADSB without a human in the loop exclusively in order to be able to determine what's happening in the vicinity, because we, again, for all the reasons we mentioned, you might not have a transponder, it might be malfunctioning, you might be out of transmission range, might be a louder aircraft somewhere in the area, or we may simply choose to discard the message because it's scrambled, we may not understand it. So again, this is safety as a kind of like layers of an onion, right? And particularly when it comes to our data, there are probably over 20 of those layers now that we're putting together, particularly in Arrow, to be able to trust this information and use it in our navigation.
Well, I have to say though, Richard, I've known you for probably about 6 years now, maybe 7 years.
Feels like longer.
It does not at all, not at all. As my boss, it's been a wonderful experience.
Sure.
The thing is though that you as a person never ever take the easy option, and you've always strived to push the barriers and stuff like that. So, for example, Operation Zenith, to bring everything together to demonstrate what you've got to do to make things safe or get things working. You seem to rise to those challenges, and I think that's what we're seeing here. This is what Altitude Angels moved on to Arrow, for example. That isn't going to be easy, but I think you actually thrive upon that, don't you, to demonstrate actually we can bring the right technologies together, and come on, let's demonstrate the industry you can do this.
Pain is the currency of change. Right? we have a penchant for pain, but no, it's the team now. Everyone is focused on doing the really difficult stuff, which is necessary to get going. As we've seen with Network Rail, as we've seen with Royal Mail, as we've seen with National Grid, it's possible to do great things with drones if you're only really focusing on yourself. So if one organisation is inwardly focused, it can go to the CAA, it can talk about its approach, it can get a certification, it's going to have an element of geography to it, so it's only going to work in a certain location at a certain time for a certain aircraft, and that's fine, that's great. But if we also want to operate there, or someone else wants to operate there, or 5 companies want to operate over interlocking infrastructure, then something else needs to happen. And it's that infrastructure related challenge, both the procedural and the physical infrastructure challenge, as well as the technological one, that we've always been really, really focused on. And that, as I've always said to our audience, to our team, to our investors, is that's a really unsexy problem that really needs to be solved.
Absolutely.
That's the one that we really aim for.
Well, I'm going to end it there on a very unsexy problem. I think perfect way to end. I hope everyone has enjoyed this. Like I say, please give us your comments if you're watching on YouTube in the comment section below, or you can drop us an email at hello@altitudeangel.com. Richard, Phil, thank you for your time. Thank you for watching, and hope to see you soon.